how do we measure survival? How do we measure mortality? And the two most common things, the two most common statistics to measure mortality and survival are death rates or mortality rates. They are usually used interchangeably. I personally prefer to call it death rates because that's what we're counting, but mortality rates is, I think, more common. So please don't get mixed up. They mean the same thing. What they exactly mean, that's what I will cover in the next few minutes, as well as life expectancy or life expectancy at birth. That's what I mean here. Very often when people talk about life expectancy, they mean life expectancy at birth. But why are we actually measuring death rates, mortality rates, and what is life expectancy? Why do we not simply count death per unit of time? In other disciplines, I guess you have the audience is very, very broad, so it's not necessarily demographers, mathematicians, actuaries. Why don't we do the same thing as in the medical sciences to measure the heart rate, so the beats per minute of the heart? For nuclear decay, we use becquerel. Why do we not just count death per unit of time? So how many deaths have occurred in a single year in a country? And the reason is hopefully relatively simple. Once you see it, those are the death counts for Sweden since 1751. So every discipline has their favorite example. For demographers, it's Sweden because it's the country with an extremely high data quality, and the time series goes back until 1751. So that's the earliest time in for any country where we have reliable data for a sizable population. And what we can see over time is hopefully that there's, of course, some issues, some problems, some catastrophic years, but it's a very strange case. And if you compare what you heard already about life expectancy, in 1950, the situation was worse than it is nowadays. But if you only count the number of deaths, the number of annual deaths, you would think otherwise. So obviously, one of the reasons why we use or why we have to use a different measurement is because population size changes over time. So a measurement which you see quite often is the so-called crude death rate, abbreviated as CDR, and by T in parentheses means like what is the crude death rate in year T. And that's usually the number of deaths in a population in a given year T divided by the average population in this year T, often abbreviated by a P, or also as often used as the abbreviation N for the population in a given year T. This is a first step to standardize for the population size, but this is actually not enough. The problem is it disregards the aging of the population. And that's what I try to sketch here. On the x-axis, you see calendar time, and on the y-axis, you see the crude death rate per 1,000. What does this mean? A value of 15 means, on average, 15 people per 1,000 died. And what we see here, this is Japan since 1947 per 1,000. And what we can actually see is that the crude death rate is going up over time. And this might be surprising because it started going up mainly in the year, or primarily like in those years when Japan became the leader in terms of longevity, in terms of life expectancy. So it seems strange that the measurement for mortality can go up when the situation is actually improving, or even more pronounced in this case, when Japan took over as the leading country in the world in terms of life expectancy. So you need to standardize for something else. And that's the aging of the population. How can you do that? Because Japanese population got older, and we already know, I think this is something I can assume that everyone is familiar with. Young people have a much lower mortality than older people. So a 20-year-old has a much lower mortality than an 80 or a 90-year-old. So if there's more people at higher ages, you automatically observe more death, although the risk at each age goes down. So you need to standardize for the population size, that's number one, and you have to standardize or take into account the aging of the population. One possibility is to estimate so-called mortality rates for a single age-specific death rates or age-specific mortality rates, usually abbreviated by an M in demography. At age X in year T is nothing but the death at this age X divided by the number of people exposed to the risk of dying in the same age X in year T. So that's one way to standardize if you only look at single ages, or if you want to look at the whole age range, the most common measurement is life expectancy at birth. I do not want to show the mathematical derivation here. It's based on age-specific death rates, but I try to plot it here on the bottom. On the bottom, you see the x-axis goes from 0 until 110, and the so-called survival function is denoted on the y-axis. At the bottom, it's 0. It means 0 survivors. And in demography, we start at 100,000. It's called the radix. In other disciplines, maybe you start with 1. It just shows how long or how many people survive until a certain age. So you see here, West German males, 1975. That's my birth year. If you look at this, you see that 90% survive until age 47, and very few people survive or survived beyond age 100. Why is it life expectancy? Is the integral, the area under the curve. Imagine we had some arrows going in parallel to the x-axis. So we would have 100,000 arrows, and you would estimate the average length of life. This is life expectancy put into simple terms. And this is the other measurement we will use throughout our module 2 on the advancing frontier of survival. Something which is often confusing, and I got asked quite often, how do you know you're alive? How do you know the survival of West German males born in 1975? And I don't want to disappoint you, but I have to. I'm very sorry. I don't know, and nobody else does, because, well, if we look at the year 1975, but now at the year 2022, on the x-axis and on the y-axis, we have the age. This is a so-called Lexis diagram. That's what we call it in demography. And it's very useful to see how a cohort ages progresses throughout their lifetimes. We see those are those born in the year 2022, and we want to know what is their life expectancy. We don't know because we're just here in the middle of 2023. So anyone born in the year 2022 cannot be older than 1 year. So if we actually want to know what's the average length of life for those born in 2022, we have to wait 100, 120 years. This is not really feasible, of course. And so usually, unless it's it's labeled as a cohort life expectancy or a generation life expectancy, which is reported by all statistical agencies, is not a cohort life expectancy, but a period life expectancy. What does period life expectancy mean? Period is, in demography, a cross-section at a single year or single years of calendar time. And what we do is then we estimate what are the death rates at age 0, what are the death rates at age 1, age 2, and so on and so on. So we make a cross section in time, and based on those death rates, there are some equations to estimate life expectancy. So this is what is actually reported, and this is also the measurement of life expectancy I want to use in the remainder of my module today. So please keep this in mind. This is not a perspective that pretending we knew how old people will be on average born in 2022 or 1975 of any cohort still alive. That's not possible. You can make some educated guesses, but what's usually reported is period life expectancy. How long would a person live on average? And that's the important part. How do we interpret period life expectancy? And it's how many years can a newborn expect to live on average, given the currently observed mortality remains unchanged for the next 100 and 120 years. People are usually surprised when they see this interpretation, but that's the valid interpretation. We would have to assume for the next 100 and 120 years life expectancy, mortality conditions remain the same to be sure that our estimate is correct. So what use is it then, you may ask? And there's a few advantages. Number one, you do not have to wait for 100, 120 years to know something about life expectancy. Number two, it's a single number, which is a weighted average about the current living or mortality conditions in a country. Number three, you can follow the trend over time to see whether things are getting better or worse. And number four, it facilitates also the comparison across countries. That's why period life expectancy is the most common measure in demography to estimate, longevity. And that is the end of lesson 1 in this module. I gave you a short introduction to how can we measure mortality, what are the pitfalls in terms of population size, aging of the population, and also that we have to be careful when we're interpreting period life expectancy. Thank you very much. We will continue in a minute or a second talking about recent trends in terms of survival and longevity. Thank you very much.